Okay, so have you ever thought about what's really going on inside your body when you take a pill? I mean, beyond just feeling better. Today, we're going to do something a little different. We're turning the science of medicine into a full-blown adventure story. We're going to follow one single drug molecule, our hero, on its epic quest, from the moment you take it until its mission is totally complete. So, let's dive in.
Seriously, it's something we just don't think about, right? You pop a pill for a headache, and poof, the headache's gone. But what's that incredible, almost unbelievable journey that happens in between? It's a microscopic odyssey, and that's exactly the story we're going to unpack right now.
All right, every great story has to start somewhere, usually with a call to adventure. Well, for our hero, this tiny drug molecule, that call to adventure comes when you're feeling sick or in pain. So this is Act 1. The mission begins.
So, let's meet our hero. It's this tiny but incredibly powerful molecule. And its mission, it's got to travel through the wild, treacherous landscape of your body to find a very specific target. We're talking about things like calming down the nerves that are screaming headache, or taking out an invading army of bacteria.
And this whole adventure? Well, it's actually a science. It's called pharmacology, and it's basically the study of how drugs and our bodies interact. You can think of it as the official rulebook for our hero's entire journey. It covers everything: what it's made of, how it travels, and how it gets the job done.
Now, our hero doesn't always start its quest in the same place. There are a few different starting points, what scientists call routes of administration. The most common one is oral. You swallow it as a pill. But it could also be injected. That's parenteral. Or maybe you breathe it in through inhalation. Or you just rub it on your skin, which is topical. And believe me, each starting point has its own unique set of challenges.
Okay, so our hero has been deployed. The mission is a go, and this is where the real trials begin. Because once it's inside your body, this is no easy, straight path. No way. It's an epic journey, and it's absolutely packed with obstacles designed to stop our little hero dead in its tracks.
So for a drug that you swallow, that first challenge is a real doozy. Imagine being dropped into a literal pit of acid. That's the stomach. It is a brutal, brutal first test of survival. And honestly, a lot of molecules don't even make it past this first stage. But if our hero does survive the stomach acid, it moves on to the small intestine. And this is the first major gateway. The walls in here are lined with thousands of these tiny finger-like things called microvilli, and they are just packed with blood vessels. This is where the magic of absorption happens. Our hero passes through the wall and finally gets onto the body's superhighway, the bloodstream.
But wait, just as our hero merges onto that superhighway, ready to race to its destination, it gets yanked off at the very first exit. It's diverted to this mandatory, no exceptions, security checkpoint. And that checkpoint is the liver. See, all the blood coming from your gut gets routed directly there. It's the body's primary filter and its toughest gatekeeper.
And here's the big problem. The liver sees our hero molecule and immediately thinks, hey, you're not from around here. It sees it as a foreign invader and starts trying to break it down on sight. This whole process is called the first pass effect. The liver metabolizes, or chews up, a huge chunk of the drug, basically making it useless before it can even get to work.
And just to give you an idea of how tough this checkpoint is, get this. For some drugs you take by mouth, as much as 95% of the original dose, that's 95% of our heroes, get wiped out by the liver on this very first pass. Only the absolute strongest, or maybe the luckiest few, actually make it through to the other side. But for those few, elite molecules that survived the acid bath, got absorbed, and slipped past the liver's first pass gauntlet, well, now the most important part of the journey begins. They've made it. They've reached their destination, and it is time for the climax of the mission.
So, how does our hero actually do its job? It all comes down to something called the drug receptor theory. It sounds complicated, but it's not. To have any effect at all, our drug molecule has to find and connect with a very specific receptor on a cell. The absolute best way to picture this is with a lock and a key. The receptor on the cell, that's the lock, and our drug molecule, that's the key.
Now, our hero can be one of two kinds of keys. First, it can be an agonist. This is like the perfect key. It slides into the lock, turns it, and activates a response. It tells a cell, hey, stop sending those pain signals. Then there's the antagonist. This is more like the wrong key that gets stuck in the lock. It fits, so it blocks the keyhole, but it doesn't turn. It just sits there, preventing any other key from getting in and starting a reaction.
And just like that, mission accomplished.
The pain is gone, the infection is clearing up. Whatever the goal was, it's done. But our hero can't just, hang out at the party forever. Its job is done, and now it's time for the great escape.
And guess who's back to supervise the exit? Yep, the liver. But this time, its role is totally different. It's not an obstacle anymore. Now it's the cleanup crew. The liver's job is to find our hero molecules still circulating in the blood, and through that process called metabolism, it changes their shape to basically switch them off.
So this whole exit strategy is really a two-step process. First up is metabolism. That's the liver chemically changing our hero into an inactive form that can dissolve in water. Then comes step 2, elimination. The blood flows to the kidneys, which act like a superfine filter, plucking these inactive molecules out and getting rid of them from the body through urine.
There's actually a way to measure how quickly this cleanup happens. It's called the elimination half-life. It's just the amount of time it takes for your body to clear out half of the drug. And that is exactly why you have to take medicine on a schedule, like every 4 or 6 hours. You're basically sending in reinforcements before the first wave of heroes is totally done, so you can keep the good effects going.
But hold on, our story isn't quite over yet. Like any good story, there's usually a twist at the end, right? Well, our heroes' powerful actions, they can sometimes have unintended consequences. And we have a name for those, side effects.
An adverse drug reaction is really just a fancy way of saying an undesired side effect. And it makes sense when you think about it. Our hero molecule is designed to be powerful, right? It's meant to interact with our body's systems. So sometimes it might accidentally fit into a lock it wasn't meant for. Or maybe its main action just causes an unexpected domino effect somewhere else.
So what actually causes these things? Well, it can be a bunch of different stuff. You can have drug interactions, which is like two different heroes trying to use the same road and causing a traffic jam. Patient factors are huge too. Everyone's body, the battlefield, is different because of things like age and genetics. Sometimes your own immune system can mistake the drug for a real enemy and launch an allergic attack. And of course, dosage is critical. Too much of a good thing can absolutely become a bad thing.
So when you boil it all down, the journey of a drug is this amazing story of chemistry, biology, and just incredible odds. And I think understanding this whole journey shows us that medicines are incredibly powerful and predictable tools. They're not magic. And by appreciating this wild adventure happening inside our own bodies, maybe we can all get a little better at using them safely and effectively. So that's our story for today. It makes you wonder, right? What other everyday science should we turn into a hero's journey next?